Imagine that you are taking part in a game show. In front of you are 3 doors. 2 of those doors have ghosts behind them, and 1 door has a brand new car, or whatever reward that will motivate you to play the game. You get to pick one of those 3 doors first. Then the host, who knows what's behind each door, deliberately picks one of the 2 goat doors. Then he asks if you want to switch your choice, or he reveals which door has the reward. Do you stick with your original door, or do you swap and pick the one that neither of you picked? This is the Monty Hall problem, and there are multiple correct answers depending on who you ask. It's a demonstration of the counterintuitive logic that mathematical probability can create. Most people are going to assume that it doesn't matter, because if you eliminate one of the goat doors, that means there are only 2 doors to pick, and you have a 50-50 shot of getting the reward. That's what I assumed at first as well. If you're thinking in pure numbers, then that is the correct answer. However, this is not a fair scenario. This is a hypothetical game show. The host already knows where the reward is, so he will pick a goat door regardless of what door you pick. This means that he has inadvertently given you information about 2 doors at once. You see, probability compounds upon itself the more times a certain chance is taken. If you roll a die multiple times in a row until you land on a 6, your first roll has a roughly 17% chance of being a 6. If you roll it twice, you have about a 30% chance of getting a 6 one of those times. If you roll the die 3 times, that's a 42% chance of getting a 6, and so on. The more times you test the odds, the more likely you are to trigger the outcome these odds are connected to. So in the instance of the 3 doors, you've picked 1 door already, which is a 1 in 3 odds. Then the host picks a goat door from the remaining 2, which means that the door neither of you picked has the higher statistical odds of being the door with the car. This only works because the host knows which door has the car. So he's filtered 2 doors at once through his single choice. There is a significantly higher chance that the door he didn't pick is the door with the car, simply because he didn't pick it. He can't pick the door with the car, because that would ruin the whole point of the show. If it were another contestant who picked a second door at random, and they just so happened to pick a goat door, then you would have a true 50-50 shot. Our understanding of probability starts to collapse once you introduce deception and human intent, because math isn't usually able to map psychological effects so cleanly like this, and we never really learned that this is even a possibility. So to us, math and game show psychology are completely separated. If I didn't force myself to think it all through, then I would have called it game show shenanigans and probably left it there. If I'm going to be really honest, by the time I had spent like 30 minutes thinking about that, this entire scenario started to feel like a mathematical example of why gambling is a bad idea. It demonstrates very explicitly that insider knowledge warps probability to a point where it's no longer truly fair. If a person made it, and a person knows how it works well enough to control it, then it is most likely not nearly as fair as it might claim to be. The Monty Hall problem sounded dumb at first, but then it made sense in a weirdly twisted way. Now I'm just left thinking that I could probably debunk gambling using nothing but math if I were any good at it. Now I'm sure somebody already has, honestly. And I'm sure we already know gambling is a bad idea anyway. As it turns out, the only truly fair things in this world are the things we can't influence.